Let's talk about conditional probability. In this case, we have a two-way table about home pregnancy tests given to women and whether the pregnancy was verified through blood tests. So we have pregnant women who tested positive and negative with the home pregnancy test. So there were a total of 74 pregnant women. And then not pregnant, there were a total of 19. 5 tested positive and 14 tested negative. So we have a positive test, negative tests, pregnant and non-pregnant women for a total of 93 people in this study. We want to find the probability that you're not pregnant given that you got a positive test result. Now there's a formula. The probability of B given A is the probability of A and B divided by the probability of A. So if we were to apply this formula blindly, we have to work out A is not pregnant and B is positive test result. So A and B, not pregnant and positive test result. We're looking at these 5 people. These are both not pregnant and a positive test result. Out of 93, we would have 5 out of 93 as the probability of not pregnant and positive test result. Divided by. Now, we're dividing by the given fact, the positive test result. How many positive test results are there total? 75 out of 93. This reduces, we could invert and multiply, to 5 over 75, which reduces further as 1/15, which we can go to percents or not, depending on if they request. So there's 1 out of a 15 chance that you're not pregnant given you got a positive test result. In other words, 15 people that get a positive test result results in 1 person actually not being pregnant. The other 14 would be. Okay. Now what's really going on here, and I think a better approach, is the fact that we're given that we got a positive test result. Basically what that does is it decreases our total space to only the ones that got a positive test result. So if we just look at that as the space that we're dealing with, and then we're looking for how many are not pregnant out of the total, we directly see it's 5 out of 75, which reduces to 1/15. I think this, instead of blindly using the formula, which works fine, gives us a little more confidence with what we're doing. So in this problem, the second part, find the probability of a positive test result given that you're not pregnant. So given that we're not pregnant, we would go to the not pregnant, in this case it's a row, and those are the only numbers that are involved. How many are a positive test result in there? 5. Over what's the total? 19. And we could look at the percent if you'd like. 26.32%. So what this says is that 26% of the time that you're not pregnant, you'll get a positive test result based off of this two-way table and the stats for this pregnancy test. Not necessarily the best situation. Now also, this demonstrates that the probability of not being pregnant given positive test result is different from the probability of positive test result given not pregnant. So P of A given B is not the same as P of B given A. They are different, and you have to work out whichever one they're asking. All right, go ahead and pause the video as you work out the questions on the right. What you should get is 3 out of 7, 3 out of 38 for the first question, 9 out of 23, and 9 out of 24, which reduces to 3/8 for the second one. All right, I hope this helps.